Example 2, solve each equation, check your solution. Okay, now example 2 specifically says solving exponential equations with unlike bases. So if you look at example A, we have 4 to the power of x equals 256. So this one we're really going to take a guess and check approach. And I'm going to say, okay, 4 to the power of what equals 256? And you can kind of mess with that on your calculator, but if it has an unlike base, the real goal here is to get it to a like base. So I'm going to keep 4 to the power of x equals, and then I'm going to look at 256 and say 4 to the power of what is really 256. So this is where I'm going to need you to go grab your calculator. So pull up Chrome. If you're working at home, let's just go to Desmos. We're going to pull up the scientific calculator, and this is where you're going to start guessing and checking. So you're going to sit here and you're going to go, okay, 4 to the power of 1, that's 4. So to the power of 2, that's 16. To the power of 3, that's 64. To the power of 4, oh, look at that. That's 256, which is what we wanted. So I go back to my paper, and instead of a question mark here, we just found out that 4 to the power of 4 is 256. Okay, we haven't changed anything. You just made it look a little bit different. But 256 and 4 to the power of 4 are the same thing. Now, the goal of that is I have like bases. And the second you have like bases, if the bases are the same, then I know the exponents have to be the same. So x equals 4. If we check that, 4 to the power of 4 equals 256. Then you would go grab your calculator. 4 to the power of 4 is 256 equals 256. And that works. Letter C, 9 to the 2x equals 3 to the x minus 6. Now, I'm looking at my bases. They're not the same. You always start with the bigger base, and we're going to try to make it match the smaller base. So if the smaller base is 3, okay, right now we are just focused on this 9. Forget everything else. And the question is, can I make a 9 into a base of 3? Because I have a 3 over here. Well, 3 to the power of 1 is 3. 3 to the power of 2 is 3 times 3, which is 9. That's what I wanted. Okay, so at the moment, you've got this thing, and 9 is the same as 3 squared. That's all we did. Now, do you remember this power of 2x? Well, you can't get rid of him. So we're still going to put a power of 2x. You just bring that down. Equals, don't touch anything over here, 3 to the power of x minus 6. Now your bases are the same. And there's only one more thing we're going to clean up before we move on. Do you notice here that you have a 2x power and you have a 2 power? Multiply them. Okay, so 2 times 2x is 4x. So we're going to keep the 3. These two are going to multiply to 4x equals keep the 3 to the power of x minus 6. Now your bases are the same. And if your bases are the same, your exponents have to be the same. So 4x equals x minus 6. We solve. So I'm going to subtract x. 3x equals negative 6. Then I'm going to divide by 3. X equals negative 2. If we check that, I'm going to go back up to the original. 9 to the power of 2 times negative 2 equals 3 to the power of negative 2 minus 6. This is going to be 9 to the power of negative 4 equals 3 to the power of, let me see, 6, 5, 6, 7, negative 8. Oh, wow. Okay, now before I can really use my calculator, there's one thing I want to think about. I'm going to say 9 to the negative 4. Well, remember, if it's a negative exponent, not a negative number, a negative exponent, we do the reciprocal. So this is going to become 1 over 9. And then my negative 4 power is going to go positive 4 power. Equals 1 over 3, and then my negative 8 power is going to go positive 8. Now I'm going to grab my calculator. I've got 9 to the 4th and 3 to the 8th. So 9 to the 4th is 6561. So this is 1 over 6561 equals, and then 1 over 3 to the 8th. Six, 5, 6, 1. And that checks out. So our answer is -2. Letter B. Okay. Different bases. So my first goal is I'm going to look at the bigger one, just focused on the 8, and I'm going to ask, well, can I get that down to a 4? Well, I know 4 to the power of 1 is 4. Well, that's not going to work. 4 to the power of 2 is 16. And I want 4. Well, that's not going to work. Well, that doesn't look right. So at this point, I'm trying to get the 8 to match the 4, and it won't. So we have to change both of them. So I have to rewrite both of them using an even smaller number. And that smaller number I'm looking at going, okay, well, 4 I know is 2 squared. Okay, all I did was change the 4 to a 2 squared. Well, now I'm curious, can I change the 8 also into a 2? Well, 2 to the 1 is 2. 2 to the 2 is 2 times 2, which is 4. 2 to the 3rd is 2 times 2 times 2, which is 8. That's what I want. So 2 to the 3rd is 8. Okay, so again, I didn't change the problem. I just made it look a little bit different. Now, at this point, this guy still had a 3x, so I still need the power of 3x. This guy still had a power of x plus 1, so I still need a power of x plus 1. Then we're going to clean up a little bit before we move on. So 2 times 3x, we get 2 to the power of 6x. This guy, we have to distribute a little. So 3 times x, we're going to have 2 to the power of 3x. And then 3 times 1 plus 3. So don't forget when you're multiplying over an addition or subtraction, you have to distribute. Now, at this point, I have the same base. So 2 to the power of something equals 2 to the power of something. Then I know that those somethings have to be the same. So I know if the bases are the same, the exponents are the same. 6x equals 3x plus 3. Solving this, subtract 3x. So 3x equals 3. Then I'm going to divide by 3. So x equals 1. If we check our answer, we're saying x is 1. Back up to the original problem. 4 to the power of 3 times 1 equals 8 to the power of 1 plus 1. 4 to the power of 3 times 1 is 3. And then 8 to the power of 2, because 1 plus 1. 4 to the power of 3, I'm going to go use my calculator. Which is 64. And then 8 times 8, 8 squared is 64. I know that one. So that checks out. And our answer was 1. Letter D, most tricky of all. Okay, so we're going to do a lot of things here. 1/3 to the x minus 1 equals 27. Now, these bases are definitely not the same. And more importantly, one's a fraction and one's a whole number. So the first guy I'm going to deal with over here is this fraction. I don't like the fraction. I like whole numbers. So I'm going to put a 1 here because that's 3 to the power of 1. And then I'm going to say, well, how do I get that to not be a fraction? And the answer is essentially we're going to do the reciprocal. We have to flip it back into the numerator. And the way you do that is with a negative exponent. So if I'm just focused on what's in here, and I flip the 3 back up to the top, but it had a power of 1, I have to make that power of 1 negative. Okay, because essentially that negative would flip it back down to the bottom. Then you still have your x minus 1 equals 27. So all we did was get rid of the fraction by making it a negative 1. Now in the next step, I'm actually going to do 2 things. First thing I'm going to do is I'm going to take the negative 1 and distribute it. So we're going to have 3 to the power of negative x plus 1. Then I'm going to look at my 27 and go, I don't like that because it's not the same as 3. Can I make a 27 into a 3? So we do some guessing and checking. 3 to the first power is 3. 3 to the second power is 3 times 3, which is 9. 3 to the third power is 3 times 3 times 3, which is 27. And that's what I want. So 3 to the third power is 27. And then it didn't have any other power, so we just leave it. At this point, I do have my bases the same. So again, if the bases are the same, that means the exponents have to be the same. So I'm going to write negative x plus 1 equals 3. Subtract 1. Negative x equals negative 1. And then divide by a negative 1 to get rid of that negative. X equals 1. Okay, then we're going to go check our answer. X equals 1. So then I'm going to have 1/3 to the power of 1 minus 1 equals 27. Well, that's going to be 1/3 to the power of 1 minus 1, which is 0, equals 27. And 1/3 to the power of 0, if you use your calculator, that's 1. This does not work, which tells me I screwed up. Okay, well, let's see. Oh, my heaven, I found it. Did you find it? Oh, back here, I subtracted 1, and then I subtracted 4. Why would I do that? Okay, that was my mistake. Let's fix it. If I subtract 1 from the left, I have to subtract 1 from the right, which is going to give me negative x equals 2. Then I would divide by negative 1, which is x equals negative 2. Okay, let's go check this and see how this works out. Okay, so 1/3 to the negative 2 minus 1, which is going to get me 1/3 to the negative 3. Okay, now for the sake of simplicity, I really want 1/3 to the power of negative 3 to be 27, so let's just go check that. So 1/3, to the power of, what did we say, negative 3? And then look at that, it's 27. So 27 equals 27, and we're good. Okay, moral of the story, always check your answer because even the teacher screws up.